Hello everyone, in this video let's discuss how to write a program to add two numbers. You are given two non-empty linked lists representing two non-negative integers. So they are given two linked lists where those numbers are non-negative integers. The digits are stored in the reverse order and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. So here we have to add two numbers. So let's assume they are giving a number called 1, 2, 3 and 4, 7, 9. So usually if I add these two numbers, what will be my sum value? 3 plus 9, which is equal to 2, and my carry is 1. So I'll put my carry here. So 7 plus 2, 9, 9 plus 1, 10. So 0, I'll put my carry here. So 4 plus 1, 5, 5 plus 1, 6. My output should be 602. Okay. But what they have mentioned in the question is, this value is given in the reverse order. That's what they have mentioned. The digits are stored in the reverse order. So which is 123 has been given in the form of 3, 2, 1. And similarly, 479 has been given in the form of 9, 7, 4. Now I have to add these two numbers. So these numbers are given in the form of linked list. So usually when I am trying to add two numbers, I will be adding from right to left. As they have given in the reverse order, I will be adding from left to right. I will be adding from left to right. So 9 plus 3, 2, that is 12. So I will put 2 here and my carry will be given to this number. So 7 plus 2, 9, 9 plus 1, 10. So I will put my 0 here and my carry will be given here. 4 plus 1, 5, 5 plus 1, 6. See, 206 is my output. So the reverse value of this will be my output value. That is what they have given in the question. The reverse order of first linked list and the reverse order of second linked list. So 2 plus 5, 7. 4 plus 6, 10. So 0 and carry will be given to the right. So 4 plus 3, 7. 7 plus 1 carry, 8. 8 is. So the output is 708. So here the head should contain this node's address, because when I am traversing my linked list, this is my first node, this is my second node and this is my third node. Similarly, when I give the linked list contains of 0, output should be 0. So in this case, when I try to add these two numbers, so here first linked list contain 1, 2, 3, 4, 5, 6, 7, 8, 7 numbers, okay, and second is 999. So here it should be 9999. Okay. Now the output should be, so I have to add from left to right because it is in the reverse order. That is why I am adding from left to right. Usually when we are adding two numbers, we will be adding from right to left. As they are given in the reverse order, I am adding it from left to right. So 9 plus 9, 18 and my carry is 1. 9 plus 9, 18. 18 plus 1, 19. So 9, my carry is 1. 9 plus 9, 18, my carry is 1, 19. 9 plus 9, 18, 18 plus 1, 9, my carry is 1. 9 plus 1, 10, 0, my carry is 1. 9 plus 1, 10, 0, my carry is 1. 9 plus 1, 10, 0, my carry is 1, so I'll put 1. So this is my output value. So 8990001. So this is the output value and this output should be in the form of linked list. Hope you are clear with the question. Now let's try to discuss the logic in detail. Okay, so here I have taken two linked lists. So this is my first linked list 243 and this is my second linked list 564. Now I am going to add these two linked lists and I am going to return the sum value. So first what I am going to do is I will write the logic here. Afterwards I will convert it as a program. So first I will create a dummy head. So what I am doing here is I am creating one dummy node. So I will keep my dummy node here. Okay, and I will initialize the value as 0. So when I am trying to initialize the value as 0, so here I will put it as null. The address of this linked list I will give 1100 and the name of this is nothing but dummy head. So I am creating a node called dummy head. Okay, this is my dummy head, not the actual head, this is my dummy head, because the final sum value should be in the form of linked list, right? So I have created one dummy head here. Now I'm going to take one more object called tail. I'll initialize the dummy head value. So dummy head is pointing to 1100. So I'll point, this is one object. Okay, I'll put one more. This I'm going to give it as tail. I have taken one more object called tail, and that is pointing to the dummy head. Done. And this is also done. Now I am going to declare one more variable called carry. Why am I taking a variable called carry? In the sense, if I add two numbers and the sum value is a 2-digit number, so the carry should be takeover, right? For that I am going to take a variable called carry. This is an integer variable. So I'll take a variable called carry. Initially I'll give my carry value as 0. So I'm going to take a variable called carry and I'm going to initialize the value as 0. Done. Okay. Now I have to add first element of the first linked list and the first element of the second linked list. I have to add value of those two nodes. For that I'm going to take a loop, that is iteration. So for that I'm going to take a loop. So in the loop what I'm going to check is, I'm going to check first element of the first linked list, first element of the second linked list is not equal to null, and my carry is not equal to 0. It should satisfy any one of the conditions. So here I'll take, this is first linked list, right? So first linked list I'll keep it as L1 so that it is easy for me to know linked list 1. So I'll put this as in a color called this. Okay. So this is my first linked list. Similarly for second linked list I'll put a different color so that we can differentiate. So this is linked list 2. Okay, this is an object which is pointing to the first node. So for that I have to, that has been given in the form of parameters. Linked list 1 object, linked list 2 object has been given in the form of parameters. So now what I'm going to do is I'm going to check that L1 not equal to null or L2 not equal to null or carry not equal to 0. If it satisfies any one condition. Okay. Why am I giving these three conditions? Since my first linked list contain elements in the linked list, or my second linked list contain elements in the linked list, or my carry value might be 1. Okay. So if it satisfies any one of the condition, I can get the sum value. That is the actual meaning. So here what I am going to do is I am going to extract the value from the first element of the first linked list and the first element of the second linked list. So for that I will be taking a variable called digit. So digit 1 is equal to, I have to extract the value from the linked list, right? For that I have to check that L1 not equal to null. If L1 is not equal to null, L1 dot data value. Okay, I am going to take ternary operator here. L1 dot val we can give, not data, because in the question they have given us val. So L1 dot val value will be taken and that will be stored in a variable called digit. If it is equal to null, I'll just give 0. Similarly, I'm going to extract the first element of the second linked list. So digit 2, I'll take one integer variable. If L2 is not equal to null, so now I'm checking L1 dot val, this is 2. 2 is not equal to null, so I'll take the value 2, that will be stored in the variable called digit. Now I'm going to second linked list. L2 not equal to null. If L2 is pointing to the address called 1000, that is not equal to null. So what I'll be doing? I'll be extracting the value. So data part from this linked list. So L2 dot val. L2 dot val. I'll extract this and that will be stored in the variable called digit 2. If it is equal to null, just I'll give 0. Fine. I have extracted this. After extracting, what I have to do? I have to add these two values. 2 plus 5 I have to add. That is being stored in the variable called digit 1 and digit 2. So I'll take sum. So first step we have to extract the digits from the linked list. After that I have to sum. Sum is equal to digit 1 plus digit 2. Please don't forget the carry, because in this case the carry value is initially 0. But what if the second case? 4 plus 6 10. So 0 will have carry 1, right? So there can be a scenario where we'll have carry value as 1. So always add the carry value. Okay, I have added the carry value. After adding the carry value, now 2 plus 5, 7. So here I have got a single digit number. There may be a scenario where I might have got a 2-digit number. If I am getting a 2-digit number, I have to add the rightmost digit in my linked list, leftmost digit in the carry value. So for that I have to extract the carry value. So I am going to take digit is equal to sum divided by 10. So here I will get the rightmost digit. Now I want to get the carry value. So how to extract the carry value? When I give sum divided by 10, quotient gives me the leftmost digit and remainder gives me the rightmost digit. So I have got the sum value, digit value that has to be added in the linked list and carry value for the next step. Okay. Now what I have to do? I have to create a node. After creating a node, I have to add the digit in the data part of the node. So first I have to create a node. So create a new node and initialize digit value. So here what I am going to do is I am going to create one node, create a new node. I have created a node. Let's give the address of this node to be 2100. Okay, I have created a node by default. Okay, let me give this so that it is easy. So 0. I have created a node. Let's assume the address of this node to be this. And here in the data part, what value I have to give? And initially is a digit value. So digit value 2 plus 5, that is 7. Digit value is 7. 7 will be given to this. Done. After this, what I am going to do is tail is pointing to dummy node next, but tail has to point to this node because this is the newly created node. When I try to add the next node, so in the address part I have to store the next node address. So tail has to be moved one step. So now what I am going to do? Move. Before which what I have to do? The newly created node's address part has to be taken and that has to be stored in the tail.next. So tail.next is equal to new node address. So here this newly created node's address has to be stored in the address part of the current tail node so that only it forms a link. So in tail.next, so tail.next is this place. Here what I am going to do? I am going to store the address part of this, that is 2100. After this I have to move to the next node. Why am I moving to the next node? Because after adding these two values, I will be creating a node, I will be adding the value. That address, new node's address has to be stored in this place. So tail, from here I will move to the next node. So how can I move? Tail is equal to tail.next. So tail, from here it will be moved to the next place. Now it's done. After that I have to add the second node of the first linked list and second node of the second linked list. So what I have to do? Automatically L1 has to be moved by one step and L2 also has to be moved by one step. For that what I have to do? L1 equal to L1.next similarly L2 equal to L2.next. So here you have to think one thing. What if this is the last node of my linked list? What if this is the last node of the linked list? I cannot move further. That might occur a runtime exception or an error. So for that I have to check one condition, that is nothing but if, that is a ternary operator I will take. L1 not equal to null means move by one step. If it is equal to null, don't do anything, just initialize a null value there. Similarly, if L2 is not equal to null means move one step. If it is equal to null, just initialize the null value. That's all. I will close my while loop. Now what I have to do? I will be in this node. So I will be in the second element of the first linked list, second element of the second linked list. Now go to the while loop, check L1 not equal to null. Actually L1 is pointing to 2000. Condition becomes true. I'll go inside. I'll extract the first digit from the second element of the first linked list and second element of the second linked list. So 4 will be stored in digit 1, 6 will be stored in digit 2. Now what I have to do? I have to add these two digits. 4 plus 6, 10. So sum value is 10 now. Here take a variable. Sum value is 10 now. Here I have to extract the digit. So digit is equal to sum modulus 10. 10 modulus 10. What is my remainder? 0. Which means 0 should be added in the next node of the linked list. So and also carry, because 10 divided by 10, my quotient value is 1. So I have got my carry value as 1. So the sum value is 10. 0 should be added in the linked list. 1 should be added to the carry variable. So digit is equal to 0. I am taking modulus, carry equal to 1 by taking the quotient value. Now what I have to do? Create a new node and initialize the digit value. So I have to create a new node. Okay, I'll create a new node. Initialize the digit value. Digit value is 0. So I'll initialize 0 here. And let's assume the address of this node to be 3100. Done. After that, what I have to do? Tail.next. So newly created node's address has to be taken. That has to be stored in tail.next. So that only it forms a link. So tail is pointing to the address called 2100. In the address part of 2100, this in the address part of the tail, what I have to do? I have to store the new node address. 3100 will be stored, which means link has been created. Now what I have to do? I have to move tail by one step. Tail equal to tail.next. 3100. Tail will be moved by one step. And then if L1 is not equal to null, I'll move L1 by one step. If L2 is not equal to null, I'll move L2 by one step. Then go for the next iteration. L1 not equal to null. Yes, L1 is not equal to null because it is pointing to the memory location called 4000. Go inside. Extract the digit 3. Then extract this node's digit 4. 3 plus 4 is 7. What is my carry value? 1. 7 plus 1, 8. Now sum value is 8. After that, extract the digit and the carry. So 8 modulus 10, my remainder is 8 and my carry is 0. Next what I have to do? I have to create a new node. Okay, I have created a new node. After creating a new node, what I have to do? I have to initialize the digit value to the new node 8. Okay, null, and the address part is assumed to be 4100 because this is a newly created node. Done. Afterwards, new node address part has to be taken. That has to be stored in tail.next. So in tail.next, I'll be storing the new node address, that is 4100, and then I'll move tail by one step. So tail equal to tail.next. So from here I'll move by one step. Now I have to check if L1 is not equal to null. L1 is 4000, so I'll move L1 by one step. So L1 will be moved to null. Then check L2 not equal to null. Yes, L2 is also not equal to null. I'll move L2 by one step. Okay. Now go for the iteration. L1 not equal to null. Actually L1 is equal to null. Check second one. L2 not equal to null. L2 is also equal to null. Okay. Check the third one. Carry not equal to 0. Actually carry is also equal to 0. So condition becomes false. I have added all the elements of the linked list. So I will come out of the while loop. After coming out of the while loop, what I have to do? Okay. Here where am I storing the first node address? This is my first node. Okay. So what I'll be doing is, I'll be taking one more object called result. I'll be taking one more object called result. Okay. In the result, what I'm going to do is dummy head dot next will be returned. Why? Because tail has been moved over there, but I have returned the head of this particular linked list. So this newly created linked list head has to be returned. So dummy head address part contain the address part of the first node for the newly created linked list. So I'll be returning dummy dot head. So I'll be taking an object. Okay, so to make it visible in one thing, I'll just move the spaces here. Okay, good. Okay, so I'll be taking one more object called result. Here what I'm going to store? Dummy head dot next. So I'll be taking one more object called result. Dummy dot head dot next is 2100. I'll be taking an object called result. So result will be pointing the address called 2100 because dummy head dot next is 2100. that will be taken, that will be stored in the object called result. So this is the object result. Now I have to make dummy head dot address part as null. So for that, dummy head dot next is equal to null. That's all. Return the result. Return result. Because now I am not going to use this, so I'll make this value as null. So this node will be automatically deleted. Dummy head will be automatically deleted because in Java garbage collection is done automatically. So this will be deleted automatically. So when I traverse the linked list, I am returning my result. So result contains the address of the first node. So this is the first node. First node value is 7. Then I'll go to the next node 3100. I'll take the value 0. Then I'll go to the next node 8. Then I'll try to go to the next node, that is null. That's all. 708 is my output value. 708 is my output value. That's all. This is the logic of the program. Now let's try to convert it as a program. Okay, what is the first step I have to do? I have to create a dummy head. So list node dummy head is equal to new list node. I'll initialize the value as 0. Done. Next, what I have to do? I have to take an object called tail. I'll be initializing the dummy head. Okay, this is what I'll be creating dummy head. Afterwards, I'll be taking an object called tail, and that will be pointing to the dummy head. Next, I'll take a variable called carry. I'll initialize the value as 0. Now what I have to do? I have to take a while loop. I have to check that first linked list. So argument contain two nodes, L1, L2. So L1 not equal to null or L2 not equal to null or carry is not equal to 0. If it satisfies any one of the condition, what I have to do? I have to extract the digits. So in digit 1 is equal to, here also I have to take a ternary operator. If L1 is not equal to null, only then I can take the value from the linked list. So if L1 is not equal to null, what I have to do? I have to take the value from this node. Say L1 dot val will be taken, else 0. Similarly, extract the digit from the second linked list. L2 not equal to null. L2 dot val will be extracted, else I will give the 0. Now I have to add those two values, that is digit 1 plus digit 2 plus carry also has to be added. After that, I have to extract the left digit as well as the right digit of the sum value. So I'll be taking a variable called digit. Sum modulus 10 gives me the right digit of the sum value. Carry is equal to sum divided by 10. Okay. So next step. After this, I have to create a new node and I have to initialize the digit value. So this is the digit which we have got. This rightmost value of the sum will be added to the linked list. For that, I'll create a new node. Linked list node. New node is equal to new list node. In the argument, I'll be passing the digit value. Fine. I have created a node. I have initialized the digit value. After that, I have to link those two nodes, right? So tail dot next is equal to new node address will be taken, that will be stored in the tail dot next. After that, I have to move tail by one step. So tail equal to tail dot next. Done. I have created a node. I have initialized a value. Next, what I have to do? I have to continue the process further. So I have to move it to the next node of the first linked list and the next node of the second linked list. For that, L1 is equal to L1. If L1 is not equal to null, move by one step. L1 dot next. Else just initialize the value as null. Similarly, L2 equal to L2 not equal to null. I'll move by one step. Okay, so I have closed the while loop here. After closing the while loop, what I have to do? I'll be done with the process. After done with the process, I'll be taking one more object called list node result. Here, what I'm going to do? I'll be storing the dummy head address part. Then I will be making the dummy head address part as null. Head dot next is equal to null. Finally return the first node of the newly created linked list. The first node of newly created linked list has been stored in the object called result. That's all. This is the implementation of the program. Let's run the code now. Yes, it passes the test cases. Let's submit the code. Yes, it passes all the test cases. That's all.